Okay, our first dihybrid cross with humans. Blood type is a really good use of a dihybrid cross because when you're mixing blood between two humans, you have to worry about two different factors at once. You're looking at their ABO blood type, that's one trait, and you're looking at their RH factor or Rhesus factor, which is a different type, but they kind of naturally go together. And if you want to safely donate blood to someone, you need to know both of those types at the same time. And that's what's happening here. So this will be a dihybrid, but before we dig into that, let's just make sure we remember all the stuff about human blood types. ABO type is determined by three different alleles, which are IA, IB, and little I. IA means you have A antigen or A markers on your blood cells. IB means you have B type markers on your blood cells. And I means no marker, no antigen on your blood cells. And so the genotypes you can get from that are, there are a bunch, unfortunately. IAIA gives you type A blood. You can have IA little I, which also gives you type A blood. This is saying put A markers on the blood cells. This says don't put anything on the blood cells, but I is a recessive trait, so it loses. You get the A marker. B works the exact same way. You can have double B, which gives you B-type blood, or you can have the B allele overriding the no marker allele, and you get B-type blood. You can have one of each, IAIB, and those two just get along great, and you have blood with both markers. Or if you have two alleles of little I, that means they agree there should be no markers on your blood, and then you get a blood type we call O, as in zero, as in no markers at all. So that covers what we call your ABO blood type. And the other feature we worry about is something called Rhesus Factor, because it was discovered in rhesus monkeys, and then it turned out that humans have the same protein the monkeys do. You can be Rh positive. Sorry, I shouldn't write it that way. The notation is just capital R. The dominant one means you are Rh positive, meaning you test positive for rhesus factor. You do have rhesus factor on your blood cells. And little r, the recessive one, stands for Rh negative, meaning you test negative for rhesus factor, you do not have it. And for this, there are three possible genotypes. Big R means you're positive, you definitely have rhesus factor. Big R means you have one of each, the dominant wins, you still have rhesus factor. And little r means you have two alleles that say don't have rhesus factor, and so you don't have it. All right, I'm going to clear that off the screen because I'm going to need the space, but if you want to meditate on that for a moment, hit pause. Okay, here it goes. Let's get to the actual question. One parent is blood type O with Rh negative blood. This is going to be easy. It's going to be easy because there's exactly one genotype that gives blood type O, and that is little I. And if you're Rh negative, there's only one way for that to happen, and it's little r. O negative people are very easy to type because there's only one way that you can have that genotype. I feel like it's probably about to get much worse. Let's see. The other parent is heterozygous. Oh, okay. I thought there was going to be some mystery here, but they're actually giving it to us. Heterozygous for blood type A. You remember there's two ways to be blood type A. One of them was IAIA, and the other one was the hetero form, this. And they're heterozygous for Rh factor, which means big R, little r. So these two people meet. If they have kids, what will be their genotypes and their phenotypes? Okay, well, Punnett graph, will it be a square? Say no. Very good, it's not a square. Why not? Here's what it's going to look like. This parent really can only produce one kind of gamete. There's only one combination they can pass on. They say, okay, well, I have to give my child one of my I's. It has to be a little I. It's all I've got. And I have to give them one of my R's. It has to be a little R. That's all I've got. So there's only one sperm cell or egg that this parent can produce, blood type wise, and it will be this every single time. Now this parent is interesting. This one can produce 4 different combinations, and we're going to need foil or some equivalent strategy to get the gametes here. I'm going to do foil, so if you're not into foiling and you have some other method, just hit mute for a moment and let's see if we get the same answer. Foiling this, I'll just put brackets around it to make the grouping more obvious. You might not need these. Okay, if we foil this, first means IA big R. The first I and the first R. Outside means far left and far right, IA little r. Inside means little I big R. And last means little I little r. Okay, so now when those combine, there are 4 possible babies that could occur. And remember, I'm going to do the I's first in order of dominance, and then the R's in order of dominance. So this goes IA little I, and then big R little r. Let me make that look a little more like the letter I, sorry. Well, okay, I can write a lowercase I can prove it too. There we go. Okay, sorry about that. Temporary breakdown of basic skills, but we're back. IA little I, and then little r, little I, big R, little r, and little I, little r, little r. Okay, so if they only wanted genotypes, we'd be done. That would be them. But they also want phenotypes, meaning actual blood types. So, what blood types do each of these represent? IAI, that's blood type A, and Rh positive, so that's A positive blood. Here we have A blood, but no rhesus factor, so that would be an A negative. Little I means no A allele at all, that's blood type O, and the big R makes it positive. And here little I means, those mean blood type O and negative. So those are the 4 things that could happen in the F1 generation.